Okay, so controller basically it is a part of process control, and controller, the name itself is control the system, control the unit, control the whole process of the industry or the factory. So basically we were also aware about the controller in our first year, or as well as our 11th 12th, and you are not, then no problem, we'll just start and study what is basically controller and why we need to control the unit to factory to operation, and which type of controller we have, and basic and what base of we made the controller. So basically controller, so we have a first we have uh, what's a proportional control. Basically the proportional controller is the itself controller which name is proportional control, P controller. It is in short call is a P controller. Basically in P controller, the output is proportional to the error. That means if you give the system like I want a 15 degree Celsius, 50 degree Celsius I want, but actually it is give me a 48 degree, so 2 degree are error. Okay, so basically proportional controller is proportional to the error. That means whatever your output is proportional to the error. So we remove the proportional sign and keep here kp, that means coefficient proportional, yani kp, it is called a proportional coefficient. Okay, the advantage is simple, fast response, reduce steady state error, but the one thing that is not good for, I mean the disadvantage or limitation we can say for proportional control is it cannot be eliminate steady state error. So steady state error, if I want a 15 degree Celsius, but it from starting it's give me 48 degree Celsius, it's not eliminate steady state starting error. So for this error, for eliminating this error, we uh, search another controller which is called integral controller. Integral controller is the output is proportional to the integral of the, that means the problem that we had which is steady state error cannot be eliminated. So in integral controller we can eliminate the steady state error. Okay, so the same thing, integral controller, the output is the proportional to the, what's it, output is a integral to the error, and for removing proportional sign we are putting here ki, which is integral coefficient. Okay, but the problem is here a proportional control is fast, simple, but the one thing here is slow, may cause overshoot. And okay, so the same thing we are with derivative control. So the problem which we had which is overshoot and instability. So we are just eliminate here, and here the derivative controller says output is proportional to the rate of change of error. So for removing what's a proportional sign, we are putting kd. Kd means the derivative coefficient. So here the good thing, I mean advantage is stable and responsible, but the same thing which is it cannot be eliminate the steady state error. Okay, so now further we are just addition of these three controller, and like pi control, that means combine p and I. P means output is proportional to the error, plus I controller which we already derive, I mean the output is integrate to the error. Okay, so both are, but where the integral controller we can eliminate the steady state error, so it's the same advantage, eliminate steady state error faster than I alone. I means integral error. Okay, so the in I this problem was I was very small, slow. The speed response is very slow. But the problem is not here. Same way, proportional derivative PD controller, combination of P, I mean P and D, yani this one. Okay, but it cannot be removed steady state error. But yes, the one thing that is fast response and improve stability. And we are just addition of these three, and which is this one combination of P, I, and D controller. The P, I, and D. Steady state error P eliminate. Okay. So this is summary table. Where I is where stability, I mean the complexity is low, but eliminate steady state error. Okay, yeah, right. Where I the eliminate steady state error is happen, otherwise it not happen. The best is PID controller. That means fast as well as very good, as well as complexity is high, but it's good. There is no problem. There is no further problem. Okay. So this is basically transfer function. The transfer function for proportional controller is KP. The same way for integral controller is Ki by S. Same way KDS, and if we combine this, then the transfer function for proportional Kp plus I. So what's for I? Ki upon S. Kd Pd, the P for Kp plus what's for Kd? Kds. Same way PID for P controller Kp, for integral Ki by S, for what's a derivative KDS. Okay. Thank you so much, guys, for